Hello, student. This is your lab session. So here we are going to discuss some Matlab implementation of digital modulation schemes. Okay. So let me share my screen. Okay. So this is your lab sheet actually. Okay. So here we are going to demonstrate, illustrate some Matlab implementation for digital modulation scheme. Okay. In this lab, mainly we are focusing on Qpsk, VFSK and Qpsk. Okay, so those three modulation we will be focusing on these three modulation schemes. Okay, okay. So we will start. Okay, so I will give you a quick recap. Okay, you know that we have if we have some information in one end, okay, so that information can be a voice, okay, image, or it may be a video, it may be a text or anything. Okay, so any information we want to send from some place to another place. Okay, so that is called communication. No, that is called communication. That is called communication. If we send this information through electrical means, it is called electrical communication or electronic communication. Okay. Uh, say a person is speaking to a microphone. Okay. Person is speaking to a microphone. Okay, like this. So this is the person. Okay, this is the person, and that person is speaking to the microphone. Okay, then his voice will be converted to an electrical signal. Okay, like this. Okay, so this electrical signal will like this. Okay, so actually this is the information signal. Okay, so we can say that it is a baseband signal. Okay, so this signal, okay, so this is the natural voice signal. Okay, so this will be an analog signal. Okay, so this signal will be analog baseband signal. Okay, and if you want to, so normally now we are using digital systems. Okay, so there are many advantage of using digital schemes for processing and for power saving. Okay, so there are many advantages. Okay, so we like to process or communicate this analog baseband signal as a digital signals. Okay, so normally so we have to convert this analog signal into a digital signal. So you can use analog to digital converter. Okay, so if you use analog to digital converter, the output will be a digital signal. Okay, so actually this is the information. Okay, so this will be a binary sequence. Okay, so this will be a binary sequence. Okay, so this is our message. Okay, so normally it may be a random bit stream. It should be a random bit stream. No. Okay, in this lab session, we start our simulation from here. Okay, so that is the first thing you should identify. Okay, so we normally we do not concern on these parts. Okay, we do not concern on these parts. Okay, so if there is any information, and that information after that information is converted to the digital bit stream. Okay, at that point we will be going to uh, start our simulation. Okay, uh, so 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 here we have a random bit stream. Okay, so that is our information. Okay, so we can say that it is our digital baseband signal. Okay, so this will be our digital baseband signal. Okay, this will be our digital baseband signal. Okay, so so this is a binary sequence. Okay, so if you want to send this binary sequence, okay, binary sequence through a line, okay, through a line, okay, let's say through a communication line, using a communication line or communication channel, through a communication channel, you have to convert this binary sequence into electrical signal. Okay, so this binary sequence should be converted to electrical signal, and there are many techniques we use to convert this kind of binary sequence to electrical signal. Okay, so that process we called line coding. Okay, line coding. So there are many line coding method. I think basic one is the NR reset unipolar. Okay, and NR reset bipolar, R reset unipolar, I reset bipolar, Manchester. So there are many line coding techniques. Okay, so anyway, we have to use a line coding techniques to convert this bit stream to a to a electrical signal. Okay, so for example, if you use the NR reset unipolar line coding technique, okay, so you normally assign one voltage, let's say 5 to one level. Okay, so for example, you can assign 5 volt for one and 0 voltage for 0. Okay, likewise you can generate electrical signal. Okay, so output will be a electrical signal like this. Okay, so this will be a 0 5 volt 0 5 volt signal. So this is a digital signal. You can see that only 2 levels are there. Okay, so few levels are there, so this will be a digital signal. Okay, so this 0, according to our technique, according to our protocol, okay, the 0 we represent using 0 voltage, and 1 we represent using 5 voltage. Okay, so this is the electrical signal. Okay, okay, so now you have to send it to a distance. Okay, now you have to send it to a distance. Okay, okay, through a communication channel. Actually, this is not a communication channel. Okay, before this binary sequence, okay, before feeding to a communication channel, you have to convert it to electrical signal so that you can use line coding techniques. Okay, so now you can send this signal through a communication channel. Okay, so that if that communication channel is simply a copper wire, okay, copper wire, you can directly send this signal, no issue. Okay, so actually we called it baseband transmission. Okay, so this is the baseband signal, our information signal. Okay, so this is our baseband, that is called baseband transmission. Okay, I think you have learned this. Okay, so anyway, if you want to send this signal, this digital baseband signal through an antenna, okay, through antenna, okay, so this kind of digital signal we can't effectively uh, communicate through antenna, because the antenna will be generating a RF signal, no? Yeah, RF signal. Sorry, electromagnetic wave. The antenna will be generating electromagnetic wave. Okay, electromagnetic wave, and it will be propagate through air. Okay, it will be propagate through air, and if there is another antenna, you can receive it. Okay, okay. So so if you feed this digital baseband signal, so this is a digital signal directly through an antenna. Okay, so this will not generate the electromagnetic wave. Okay, so maybe very weak electromagnetic wave can be generated. Okay, but it will not propagate it. Okay, and also we can't reconstruct this signal using the received signal. Okay, so we have to do another method. We have to use another method. Okay, so you know that RF signals, electromagnetic wave, are normally sinusoidal in nature, like this. Okay, so this frequency will be in RF range. Okay, RF range, I can't remember the RF range clearly. Okay, so you can Google it. Okay, so I think it is 30 megahertz maybe. Okay, it should be greater than 30 megahertz. Okay, Um, so this will be the so so you have to convert. Okay, so this kind of signal, if you feed this kind of signal, electrical signal. Okay, that means if you feed a signal, sinusoidal signal with RF, in RF frequency range. Okay, so the antenna can effectively generate electromagnetic wave, and antenna also can effectively propagate it through the air. Okay, so we have to convert this signal into a uh, this kind of uh, high frequency signal, high frequency analog signal. Okay, so actually that signal we called as pass band. I think you can remember these things, pass band. Okay, so we have to convert this baseband signal into a pass band signal. Okay, so that we are using modulation for that purpose. Okay, modulation techniques. Okay, so in this modulation scheme, you can see that our information will be a digital signal. Okay, our information will be a digital signal. Okay, information is a digital signal, digital information, and we have to convert this digital signal into a analog RF frequency range signal. Okay, for that we have to use a carrier signal. Okay, we have to use a carrier signal, and that carrier signal should be in RF level, RF range. Okay, range, and it should be a analog signal or sinusoidal signal. Okay, so so that you can see that our our information is our informations are digital, and our carrier signal is analog one. Okay, so we are using several techniques. Okay, in this uh, modulation schemes. Okay, so if I tell you the name, you already know that we can use FSK. Okay, ASK, FSK, PSK. So these are the three basic method. Okay, so so already you know that the basic the most basic scheme is related with ASK is BPSK, binary BASK, binary amplitude shift key, and for this, with this it is BFSK, binary frequency shift key, and with phase shift key it is binary phase shift key, BPSK. Okay, and also we can use the higher order modulation scheme also. Okay, so several symbols can be sent at once. Okay, sorry, several bit can be mapped to one symbol, and it can be sent at once. Okay, so another next order PSK after the BPSK, we can the next order phase shift key modulation scheme is QPSK. Quadrature phase shift key. Okay, so I'm not going to tell the details about it because you have already known this. Okay, and I think there is another very popular schemes is there. Okay, that implemented. Okay, that was implemented combining this ASK and PSK, both ASK and PSK. Okay, so it is called CAM. Okay, so this is the very this one is the most popular modulation scheme. Okay, so you can achieve achieve a higher data rate using this CAM modulation techniques. Okay, so these are the basic modulation techniques we are using for this modulation. Okay, digital signal to convert digital signal into a analog carrier signal. Okay, so in this lab we are mainly focusing on this BFSK, BPSK and QPSK. Okay, so you can see that after the line coding techniques, okay, after the line coding technique, we should have that modulation scheme. Okay, modulation scheme. Okay, then if you feed this baseband digital signal into the modulator, okay, then the modulated signal will come out. Okay, and you can directly feed it to the antenna. Maybe you have to amplify it. Okay, but here we are not in this schemes, in this simulation we are not uh, deal with those stages. Okay, amplification stages, uh, maybe some filtering stages. We we usually do not deal with those type of stage. Okay, so we mainly focusing on these stages. Okay, so we have random bit stream, and we have line coding techniques, then we have a modulation scheme. Okay, then after this signal is propagated through air, so another antenna, the receiver antenna, so this will be a transmission antenna, and receiving antenna will receive the signal and it demodulate the signal. Okay, and it demodulate the signal and encode these bits again. Okay, encode this bit again. Okay, so these are the stages we mainly focusing on. The generating, so if I write it here. Okay, so these are the main point we are mainly focusing on: generating message signal. Okay, then generating electrical signal, that is line coding. Okay, line coding. Okay, then generating RF passband signal, generating the passband signal, that is we call modulation. Okay, modulation. Okay, and so this is the coding. Okay, and after send this signal, we have to demodulate it. Okay, we have to demodulate it, and we have to encode the message. Okay, so these 1, 2, 3, 4, 5, these 5 stage. Okay, we will be mainly focusing on these 5 stage. Okay, so that is the idea you should get. Okay, so now I think we can start the Matlab simulation. Okay, so I will go to the Matlab screen. Okay, so you know that so here this is our, so let me show you. So this is our lab sheet. Okay, so this will be our lab sheet. So you can see that here you can see that generating carrier signal. Okay, generating binary data message signal. Okay, so there are many activities we have to do. Okay, so these activities actually should be done by you. Okay, should be done by you, and Matlab code, one Matlab code also given. Okay, relevant Matlab codes are also given. Okay, but maybe actually these programs are not coded by me. Okay, these Matlab codes. Okay, so actually so you can see that it is an image. Okay, so it is hard to copy and paste. Okay, so maybe when I am going to do some when I write codes. Okay, maybe those are not directly equal to these codes. Okay, So I think it will not be an issue, okay, because we can have different approach, okay, we can have different approach to implement one thing, to implement a certain task, okay, to implement a certain task. Normally we can have different approach, okay, but conceptually all these are same, okay. So I think you will be able to understand them, okay. So what I want to tell you is that when so if I write some codes, okay, maybe those are not directly related to this codes, okay. Actually I didn't test this code also, okay, because I have to type those by one, okay. So it is very boring, okay. So I'm not going to actually I didn't check this, test this, okay, but you can do this, okay. Okay, so we will start, okay. And one thing I should remember you, okay. So I am so you have to do this activity, okay. So you have to do these activities by yourself, okay. I am going to tell you some outlines, okay. Outlines, it is a guide, some kind of guides to achieve this task, okay. So let's start, okay. So what is our first stage? That is generating a random signal, okay. So very simply you can generate a random signal using this command, okay. So if you want to find more details about this command, you can Google it, okay. You can Google it. So actually we will have a jump start, okay. If you want to know some details, you have to use the other resource also. So it is run in Matlab. So just type it like this, okay. So you can have that code, okay. So here all these things are explained, okay. Okay. Yeah. Okay. Let's say that generating random signal lab in Matlab. Okay. So you can see that. Why I'm not directed to the. So anyway, so you can find the details here. Okay. Actually, if you write this, normally that we are given that website. Okay. So this is rand I. Okay. So rand I. Okay. Rand I in MATLAB. Okay. So you can see that you are given you are given all details. Okay. So always go to this website. Okay. The Matlab website, so you can get the full details about full details on any codes, okay, on any Matlab codes, okay, with examples, okay. So you can understand very easily, okay. So you can see that here using this command we can generate uniformly distributed pseudo random integer, okay. So that means uniformly distributed means, I think you already know that, okay. So that means so if we are going to generate four random numbers, okay, four random numbers like this, okay, so all these four random numbers will have the same probability like this, 1 by 4, 1 by 4. So that is uniform distribution. Okay, so here we are going to generate two bits, actually 0 and 1. Okay, so that 0 will have, the occurrence of 0 will have half probability, and of occurrence of 1 will have half probability. Okay, so that is the idea. Okay, so let's go to the Matlab again. Okay, so here you can write it like this. Okay, so so you already know that these commands are to clear this workspace. Okay, then here I have so I will explain this one. Okay, so here you can write this command like this. Okay, so here you you so actually here you are generating array. Okay, you are generating array. For example, if I show this to you, let's take this n as 10. Okay, so if I run this, okay, so if I run this, you can see that here m, okay, this m will generate a array, no? So there are three. So, on this, okay, so you can see that okay, so this one we have to delete. Okay, so if I run this, okay, so you can see that we will have 10 bits. Okay, 10 bits, 10 binary numbers, 1 0 1 0. Okay, so these are uniformly distributed random numbers. Okay, and we will get 1 into 10 array. So this is 1 by 10 array, 1 into 10 array. Okay, so so this is how you defined it. Okay, so so if you write it, you can see that if m is equal to rand I, okay, so you have to put the bracket. Okay, you have to put the bracket. Okay, then you can have this what is this syntax. Okay, so so here you have to put the one way is you have to put the maximum number. If you put the 10, if you put 10, so it will generate 1 2 3 4 like integer up to 10. So maximum number will be 10. Okay, and here here you can also define the number, the value number. So if you use 5 here, so it will generate 5 numbers. Okay, likewise. Okay, and actually I use this method. Okay, so here I use the minimum value and the maximum value. So my minimum value will be 0 and my maximum value will be 1, because I only need 1 and 0. Okay, 0 1. Okay, then okay, then I close the bracket, then I put the array size. Okay, so first one is row, so I will use 1 row. Okay, and number of bits, that will be our columns, no, number of bits. If you want to generate 10 bits or 20 bits or anything, you can put that number here. Okay, okay, so it is according to your program. Okay, sometimes you may have to generate very huge number of message message bit. Okay, so here you can see that you can generate 1 by 20 array. So 20 information bits are there, 0 0 1 1 like this. Okay, so here this n can be changed. So this is the length of the message signal. Okay, so from program to program, so this can be changed. So I will set it as a variable and I defined it here. Okay, so I do like this. Okay, so using this command, I can generate any message signal. Okay, so that is okay. So next one is, the next step is, I think you can remember that we have to do the we have to do the line coding. Okay, so let's see how we can achieve the line coding. Okay, so this is also very important. Let's see.